Today we're looking at how to solve two linear equations at the same time using their graphs. So when we look at two or more equations at the same time, we call them simultaneous equations. So to look at the point of intersection of two lines, we can use an accurate graph and find the coordinates of the point where the two lines cross. So when we're talking about straight line graphs, where there's two situations that can happen. We get one point of intersection, which is called our solution, and the coordinates of that point of intersection are the solution to the simultaneous equations. Or once we've graphed our lines, we may see that they're parallel, and that means that there's not going to be a point of intersection, so those two lines don't actually have a simultaneous solution. This is just a visual representation of the solution to simultaneous equations. So obviously, where we've got the point of intersection, our solution is the coordinates x, y. And where our lines are parallel, there's no solution at all because you can see they will never touch. I've just got two examples for us to go through today. So our first one, we need to decide if the given point is at the intersection of the two lines with the given equation. So our first equation is y equals 2x plus 3, and our second equation is y equals negative x. So what we're testing is we're testing whether they both run through the point negative 1, 1. So to be able to test that point for both equations, we're just going to sub in the x value of negative 1 into both equations and see what the y value is. If that point satisfies both of those equations, then our y value should be 1 for both of them. So substituting x equals 1 into y equals 2x plus 3, we've got y equals 2 times negative 1 plus 3, which gives us 1. So that means the point negative 1, 1 satisfies that equation. And subbing our x value into our other equation, y equals negative x, we get y equals negative of negative 1, which is, of course, positive 1. So that point actually satisfies that equation as well. So it's important to write a finishing sentence or your solution. So you say, therefore, negative 1, 1 satisfies both equations, or therefore, negative 1, 1 is the simultaneous solution to these equations. And for our second example, we're being asked to solve a pair of simultaneous equations graphically. Now, it's important, if you're asked to solve them graphically, you must draw a graph. It's not a case of, oh, well, I can kind of, work out what x should be and what y should be for both of those. You won't get any marks if you don't solve it the way the question has asked you to. And I think it's important just to recap here how we actually graph equations. So of course you can draw up a table of values and work out some coordinates to be able to draw the line, or the easier way is to just draw the lines from the intercepts. Okay, so we've got our first equation, y equals 2x minus 2. That's written in gradient intercept form, so we can just read the y-intercept straight off. That's going to be negative 2. And we need a second point to graph as well. So we'll get the x-intercept. Of course, the x-intercept occurs when y is equal to 0. So you just sub in y equals 0 into your equation. So you've got 2x minus 2 equals 0. Obviously, 2x is 2. X is going to be 1. So there are your two intercepts to enable you to draw the equation. Looking at our other equation, x plus y equals 4, it's not so clear now. It's not written in gradient intercept form. You can make it into gradient intercept form if you want to, or you can simply sub in x equals 0 to find the y-intercept. It's a matter of personal preference. I've just chosen to sub in. So, of course, I'm subbing in x equals 0. 0 plus y is 4. So, of course, y is 4. So y equals 4 is my y-intercept. Doing the same thing for the x-intercept, I'm going to now sub in that y is equal to 0. And of course, I'm going to come up with x equals 4 as well. So I've got both my x and y-intercepts are equal to 4 on that graph. Then now to draw our graphs, of course, we're going to start with our intercepts and join them up. And once we've got our two lines drawn, we can see our point of intersection. So from the graph, we can see that our point of intersection occurs at 2, 2. So again, it's really important to write your finishing sentence from the graph, the simultaneous solution to the equations y equals 2x minus 2 and x plus y equals 4 is 2, 2. You must explain what you have done. Say that you know that's a simultaneous solution. Don't just draw the graph and be done with it. Okay. Point out that you know the point of intersection is the simultaneous solution.